right, we are a group of Cal polyQuakes. Our project is called Slow Vibes. My name is Michael Balnick. We have Weston Gilmore, Jackson Dimer, and James Plasko as part of the team. Our client is Dr. Ramos, and of course our instructor is Dr. John Oliver. We broke it. There we go. All right, I would like to introduce you to the CP Slow Seismic Station. This is a seismic station installed in the summer of 2017. Here you can see the Seismic Station Vault, a concrete tub with instrumentation, data loggers in it, a solar array with GPS and network capabilities. This station is part of the Southern California Earthquake Data Center. It takes seismic activity readings on campus. It is located on the corner of Highland and California, right out here next to the train tracks. This station has two instrumentations on it, an SM or strong motion and BB broadband monitors. It takes accelerometer measurement readings and relays that back to the SDEDC. It's capable of measuring earthquakes and other events. We are told by the professor that the broadband monitor can pick up weather events, train horns, the daily trains that are passing by. Okay. The Southern California Earthquake Data Center itself is the primary archive for seismological data for Southern California. It's run by Caltech Seismological Laboratory in LA. It is part of a larger network called the Southern California Seismic Network. It gets funding from the USGS and some other alphabet groups for the government. It all relays data into a much larger network that other groups are able to access and get this data from. This is important because of our client, Dr. Ramos. He was responsible for installing the station with a group of undergraduates in 2017. He has a PhD in geotechnical earthquake engineering. He teaches earthquakes, geotechnical, and risk engineering here at Cal Poly. And this is an example of something that you could pull from the station or other stations within the network, grabbing time-sensitive data. There's a lot of ways to analyze it, but basically just the straight data recorded by time from the individual sensors and be able to analyze it for the different types of waves that you're seeing. Our client wants us to do exactly that. He wants us to pull the data from our station after it has been relayed to the network and store it at the data center and bring it back down and present it back to the school. He wants a real-time monitoring, special event analysis, and an easy, understandable process. He also wants us to deliver educational insights on earthquakes and risk management. This is, I don't know how many of you guys remember, this is his prototype that he showed during his client presentation, and we're going to be working with this in mind, the capabilities of the station and the data center and creating our product. This is an example of the SDEDC website. This is pulled very recently, actually. This is what you will get if you check their website, type in the name of the station, which is exactly CP Slow, and this will give you the sensor types that are there, latitude, longitude of where it's at, and you can follow some links into very large rabbit holes on analyzing and checking this data out. It gets very, very technical very quick. I'm going to hand it off here for Weston to go further.
So I'll be talking about our design requirements, but first I'll mention some of the obstacles we encountered when undertaking the project. After talking to Dr. Moss, he pretty much told us, yeah, I want the screen, pretty self-explanatory. So we know there's screens set up around campus, and so we decided to talk with some of the departments that have screens up to see if they can give us any advice or help setting it up. And it was just hey, go over here, talk to these people. No, now you go over here, talk to these people. So we ran around in circles for an hour and a half and pretty much discovered that it's Cal Poly learn by doing it yourself. Our advice from Dr. Moss is like, if we keep waiting for the administration to get things done, we might not get it done by the end of the year. So we're just going to do it and then ask forgiveness once it's already completed and up in building 13. So here's our concept fan. We started with just splitting it up into 2 sections, software and hardware. So for our hardware, we have to have a computer for processing, we have to have a screen for displaying it, and internet connectivity for querying data and pulling the waveforms. On our software side, we're going to have some graphical interface, a method for updating the information, and something for formatting the data, because we're pulling down, they're called mini-seed files that are specifically for seismic readings, and there's not a lot of software out there that's able to process these and display them as waveforms. So there's our concept fan. So our first decision matrix I'm going to go through is for our computer. So we had to choose between a desktop, a laptop, or the Raspberry Pi. And performance was really important, cost is important, and setup and maintenance are important. But Raspberry Pi ended up winning just because it's cheap, it's really affordable. We don't want to spend $1,000 for a laptop just to run a little display. Second matrix is for our graphical interface. PowerPoint, I think everyone's an expert on PowerPoint. We're all very familiar with it, but as far as feasibility goes, it's not capable of doing what we need it to do. So feasibility is the most important, the highest weighted option, and so we decided on HTML. Last decision matrix I'll go through is for the wave processing. I don't know that MATLAB's easy, but we have some members who are familiar with it. And so we weighed that the highest ease of use. And it's available to all students through Cal Poly. So we decided to use MATLAB for processing the data. And so our final design is going to be similar to this. We have our Raspberry Pi, which is querying data from the EDC, the Southern California Earthquake Data Center. It's pulling the mini-seed files back onto the Pi, and it's running the files through MATLAB to get visual waveforms, and it has to embed it onto the screen to display the waveforms. And hopefully we'll have some really cool other information on the display also. So I guess we're gonna open it up to questions now.
Yeah, we have the prototype ready to go right after this, but we'll do questions first.
You mentioned there's no more software that displays files. Let's see how we can get from this.
It's called a mini-seed.
It's I haven't opened it up and looked at the binary or whatever it is, but there's mini seed, there's seed, and there's a couple programs. There's what's called IRIS, which is the International Research Institute for Seismology, and they create software under the for all these different groups and for the government. Incorporated Research Institutes for Seismology, and they create the protocols and the software to go through and collect and do all this data. It's actually one of the reasons we picked MATLAB is because they created a Java library and some MATLAB code to use that library to pull data down, and it will use some plotting functions that they built to plot this mini-seed data. It has everything from what type of sensor you're actually querying, the type of data it is, and so there's a bunch of metadata also in these different seed formats, and it depends on which one you're actually plotting. It gets complicated really quickly. The IRIS website actually has a huge wealth of different software things to look at and choose from. But a bunch have been deprecated or just follow broken links. And so we're not sure the best way to actually pull this data down. We picked MATLAB because of our familiarity with it so far.
Is the image on the left for that final design taken from the website? or are you?
No, that's just another mock-up. We have some mock-ups. None of us are too high up on our HTML right now, so we mostly have mock-ups on how we want it to look. It's going to be one of our main 2 tasks is getting the page put together. We don't plan on hosting it separately. We're doing an HTML for the future purpose that if we get this running, he is able to take this page, and then if we get it on a domain and running, then he will be able to create multiple of these displays in other places. For now, the reason we have the Raspberry Pi is that we're going to have it working locally on one system. It needs the network connection to pull the data, but it's just going to be an HTML page open on a computer and not actually hosted anywhere. And so but we wanted the future capability to get this hosted and running, and possibly have the ability for him to have multiple screens in other places.
Is the data for like the radius and center of earthquakes, is that given in the files, in the mini-seed files?
Well, the mini-seed files are exactly, it depends on how you query it. You can query multiple stations, and there's different analysis tools. We were thinking of demoing some of the different tools that we've looked at a little bit. We are going to show one aspect of it, of how we can query some data specifically. But because you're only getting stuff from one station, it is just that waveform data that you're grabbing. You can grab different things, analyze how long it's been down. There's root mean square deviations from other data points. It gets incredibly technical unless you grab multiple stations, which I believe the Iris software can do and analyze in other ways to actually, like, you can visualize an earthquake propagating from one center to another, but you would need to grab all the data from all the stations that you would want to show that propagation.
This was a map that was on the Southern California Seismic Network. You can search by area and find recent. So this was actually I got it yesterday, so it's actually 20 days old, but this was a recent earthquake from last month.
Any other questions?
Would it be easier just to get the pictures from the website than doing the Iris portion?
The data is just stored in that mini-seed format. There aren't any pictures. You request the data, you get that in packets, depending on how you requested it, and then you're going to have to format it and actually plot it yourself. So there's a couple web services that you can manually put in some information, and we tried that for our station on one of the web services that they provided, but our station would not come up. It would not plot anything. Tried it for some other stations within our network, and it did work with a plot. So we looked into that, but for one, our station wasn't working. But we're looking at one of the requirements, or what he really wants is current, pretty much live data coming through, and these queries are only supposed to happen so often. So we're planning on getting a query system working and then figuring out how to automate it so that we can either see the narrowest time frame that we can grab data and then display it. The Iris, I keep researching it. They actually do have a live feed option to hooking up to their data centers, but it's one of those things that gets real complicated. Again, they have so many different options and things, but some of them have been deprecated. And so, anything else? Show